This video is presented by AmazingPhysicsForAll.com. What will happen when our sun runs out of its fuel? Let us find out. The sun, the star of our planetary system, is the most massive object in our solar system. It holds almost 99% of the mass of the entire solar system. The combined mass of everything else in the solar system accounts for only 1%. It is a simple fact that life on Earth cannot exist without the sun. It supplies energy needed to sustain life on our planet. That explains why many cultures revere and worship the sun. Look at the picture of our home galaxy, Milky Way. It has 100 to 200 billion stars. Our sun is just one of them, located in a place which is 28,000 light-years away from the center of the Milky Way. The red arrow shows where our sun is located. The sun is made of hydrogen 92.1%, helium 7.8%, and other elements 0.1%. Its radius is 695,500 kilometers. Compare this with the radius of our Earth, which is 6,378 kilometers. We can fill the sun with 1.3 million Earths. What powers the sun is the thermonuclear process known as nuclear fusion. In the sun's core, hydrogen nuclei, under enormous pressure and heat due to gravity, fuse together to produce helium nuclei. This nuclear fusion process produces massive amounts of energy. Can you guess how much energy it produces every second? In its core, the sun burns 600 million tons of hydrogen every second, producing 596 million tons of helium. What about the missing 4 million tons? These 4 million tons of mass are transformed into pure energy. When we compute the energy released by the missing mass, we get an astronomical number, 360 septillion watts, 360 followed by 24 zeros. Just to put a context to this enormity, this is equivalent to 4 million years of electricity usage by the entire world. What powers the sun is this incredible amount of energy released every second in the core. Let us learn how the life cycle of our sun. Currently our sun is in what is known as main sequence stage. It will remain in this stage for another 5 billion years and will continue to burn hydrogen in the core. While in the main sequence stage, the nuclear fusion process in the core keeps the sun stable. Take a look at the illustration. The immense amount of energy released in the core by the fusion process creates outward radiation pressure, which supports the huge mass of the sun and prevents it from collapsing due to gravity. Though this balancing act is delicate, it will continue to be stable until there is no more hydrogen in the core to burn. When this happens, the next stage in the evolution of our star begins. When the sun runs out of hydrogen, in about 5 billion years from now, hydrogen burning stops and there is no outward radiation pressure anymore. That tips the balance in favor of gravity. The sun starts collapsing towards the core. This collapsing pressure causes the remaining hydrogen in the shell, wrapped around the core, to fuse. This shell fusion makes the outer layers of the sun expand to become a red giant star. During this stage, sun becomes so large that the planet Mercury will be engulfed by the sun. The sun will remain in the red giant phase for about 400 million years. During the red giant phase, the helium core, the leftover hydrogen burning, gets compressed and becomes hotter. As a result, the helium starts burning, producing carbon and oxygen. What happens when the helium core is fully burned? Will the carbon core start burn? The sun's mass is not big enough to create the amount of pressure needed in the core to ignite carbon burning. At this stage, in the absence of any outward pressure, gravity will take over. The force of gravity will collapse the sun into a dense object known as a white dwarf, while the outer layers are blown away to become a planetary nebula that will engulf the region beyond the orbit of our beautiful Earth. Remaining inner orbit planets Venus, Earth, and Mars will all be engulfed at this time. The white dwarf, thus formed with most of the mass of the sun, will be compressed to the size of our Earth with extremely high density. A teaspoon of white dwarf material would weigh about 15 tons. Though there will be no burning taking place in the core now, the white dwarf will still be extremely hot and will be radiating light and heat for billions of years, but of course, in extremely reduced luminosity. To conclude, when the sun runs out of fuel, in about 5 billion years, it will first become a red giant to engulf all the inner planets and then turn itself into a dense white dwarf, eventually to become a black dwarf after about 100 billion years. If you would like to read more on similar topics, please visit AmazingPhysicsForAll.com. Thanks for watching.